Hi, it's me, Dr. Prasad Puthiyillam, continuing my series on classes on inorganic laboratory. This class is for alkalinity. Alkalinity, it is it is the water sample's capacity to act as a base, or which reacts with the proton or H plus. So in industries, industrial areas, or in near the laboratories, the water may be alkaline because it may contain carbonate or bicarbonate, or in groundwater where we use the fertilizers, there also the water may become alkaline. So how to determine the alkalinity of water? Alkalinity of water we represent, it is due to that of hydroxyl ion, carbonate, CO3 2 minus, and bicarbonate ions. The addition of acid to alkaline water is the easy method to estimate the alkalinity of water. So the hydroxyl will neutralize to water, carbonate combines with H plus proton to become bicarbonate, and that bicarbonate will be further converted into carbon dioxide and water, or if separate bicarbonate is there, that also will react with H plus to form water and carbon dioxide. Therefore, these two reactions, it can be easily estimated with an acid in present with the help of a phenolphthalein indicator. P represents phenolphthalein indicator, whereas all the three reactions can be estimated or can be determined by using methyl orange as indicator. Therefore, the phenolphthalein, it will work in a pH range of 8.3 to 10, and methyl orange, it works in a pH range of 3.2 to 4.2. So if I represent P as the phenolphthalein alkalinity means it is alkalinity due to OH minus and alkalinity due to carbonate. But carbonate converted into bicarbonate, that alkalinity is not included in this. That's why we can say that half of carbonate alkalinity is included. Therefore, phenolphthalein alkalinity represents the alkalinity due to hydroxyl ion and half of that of carbonate. Whereas M represents the methyl orange alkalinity, or it is the total alkalinity, because methyl orange indicator it can use to determine alkalinity of OH minus, carbonate to bicarbonate, then separate bicarbonate alkalinity can be estimated. Therefore, we can say it is total alkalinity. So based on that, if the phenolphthalein alkalinity value it is found to be 0, that means both OH minus and carbonate are absent. That means here represent we can see phenolphthalein alkalinity 0 means hydroxyl ion is not there, carbonate ion is also not, only bicarbonate ions are present. Therefore, alkalinity is due to bicarbonate only. If P, the phenolphthalein alkalinity, is half of that of a total alkalinity or half of that of a methyl orange alkalinity, only carbonate is present. Since half of carbonate neutralization reaction takes place with the phenolphthalein indicator, while complete carbonate neutralization takes place when methyl orange indicator is used. Therefore, alkalinity due to carbonate will be 2 into that of P. Third point, if P is equal to M, or phenolphthalein alkalinity is equal to methyl orange alkalinity, that means only OH minus is present, because both OH minus and OH minus can be estimated with phenolphthalein as well as methyl orange. Therefore, alkalinity due to OH minus will be equal to P, or it will be equal to M. If the phenolphthalein alkalinity is higher than that of half of the methyl orange alkalinity or total alkalinity, that means both OH minus and carbonate are present. Now half of the carbonate is equivalent to M minus P. Therefore, alkalinity due to carbonate is 2 into M minus P, and alkalinity due to OH minus is M minus 2 into M minus P, or can rewrite as 2P minus M. If P is less than that of half of M, that means carbonate and bicarbonate are present. Alkalinity due to carbonate will be 2P, 2 into that of phenolphthalein alkalinity, and alkalinity due to bicarbonate will be M minus 2 into P. So the indicator used for estimation of alkalinity with acid, they are phenolphthalein. Phenolphthalein at pH 0 to 8.3, that is acidic pH or near neutral pH. Phenolphthalein structure is given which is colorless. Whereas if the pH value is 8.3 to 10, that is when it becomes basic, it is pink in color. That means phenolphthalein indicator is pink in basic solution and becomes colorless when it becomes acidic. Same way methyl orange structures are given here. It is also pH dependent. Above pH 4.4, it is yellow in color. Below pH 3.1, it is red in color. That means methyl orange can be used in a pH range of 3.2 to 4.5. how to estimate the alkalinity due to carbonate and bicarbonate. Here I am not considering that of hydroxyl ion, only carbonate and bicarbonate is there. So the solution in laboratory to understand how the method, how to estimate the alkalinity by the Tetri method, we usually prepare the solution than taking the sample from the actual sample. We prepare the sample in our lab itself. Therefore, such type of samples can be prepared by weighing sodium carbonate and sodium bicarbonate and mixed in a 100 ml standard flask, dissolved and shaken well for uniform concentration. And borax solution is prepared to standardize the acid HCl that we use for the estimation. Borax solution, borax crystals were weighed and transferred to 100 ml. So I am giving the example of 100 ml solution. One can go for 50 ml or 250 ml as they wish. Borax actually we call it as sodium borate or sodium tetraborate or disodium tetraborate. If it is disodium tetraborate, molecular formula is given Na2B4O5 OH 4 times 8H2O. Its structure, molecular structure is given having two Na plus present in that, two negative charges are so there. The borax solution prepared is in 100 ml, therefore its strength or normality you can calculate as weight of borax by equivalent weight multiplied by 10. Since we prepared only 100 ml, we calculate normality in terms of liter. Therefore, liter 10, 100 multiplied by 10. The equivalent weight of borax, molecular weight of borax is 381.36. Therefore, equivalent weight of borax is 381.36 divided by 2 because it ionizes 2 Na plus is there. Approximately 0.1 normal HCl solution we prepare, and that we will standardize using the standard borax solution by using methyl orange indicator. We'll get the titer value of the solution and titer value. Using that we calculate the strength of HCl or its normality, that is normality into volume of borax divided by volume of HCl. Now determination of alkalinity due to carbonate. Okay, using phenolphthalein indicator. So whatever value obtained, if using phenolphthalein indicator, we will get only the carbonate conversion to bicarbonate. That converted bicarbonates alkalinity we cannot find out. Therefore, whatever value obtained should be multiplied by 2. In conical flask, we will take a 10 ml of alkaline solution plus phenolphthalein indicator. Endpoint, that is color change from basic to acidic, that is pink to colorless with phenolphthalein indicator. Therefore, strength of carbonate solution of that alkaline solution is calculating separately carbonate, that is normality in the volume of HCl divided by volume of alkaline solution, and amount of carbonate in 100 ml, that will be normality of calculated here multiplied by molecular mass of carbonate divided by 10. Since we have only 100 ml solution we prepared, and we represent, we have to calculate based on the normality concept, therefore we divide by 10. Let this weight as W1 gram. Here molecular mass of carbonate is 60.01, molecular mass of bicarbonate is 61.01, one extra hydrogen is there. So W1 gram of carbonate is obtained. Here the obtained volume HCl, let it be V1, the titer value, whatever after doing titration, the concordant value obtained, let us take it as V1 ml, because when we want to find out the alkalinity due to carbonate, this one we have to use, there we have to multiply it by 2. Okay, so that will come to the next slide, I'll explain. So determinant of alkalinity due to bicarbonate using methyl orange indicator. In conical flask, we will take the 10 ml of alkaline solution. You can take 25 ml. Then accordingly you have to do the calculation. So let me take 10 ml of alkaline solution. Methyl orange indicator is used. Titrated with hydrochloric HCl solution. End point will be basic to acidic, that is golden yellow to colorless solution. The volume of HCl consumed here in titer value obtained, the concordant value we took it as V2 ml. Therefore, the actual volume of HCl used only for bicarbonate, that will be V3, that is V2 minus 2 into V1. That V1 you obtained by a separate iteration done with phenolphthalein indicator. Therefore, V2 minus 2 V1, that is the volume that we have to use for calculation. Therefore, strength of bicarbonate solution will be normality in the volume of HCl divided by volume of alkaline solution. That value will get the normality of bicarbonate. Therefore, amount of bicarbonate is equal to normality into molecular mass divided by 10. Since we took only, we prepare only 100 ml solution. Let it be W2. So here molecular mass of bicarbonate is 61.01 or 61.008. Therefore, the total alkalinity due to carbonate and bicarbonate. So we prepare a solution with only carbonate and bicarbonate. Hydroxyl is not there. Therefore, alkalinity due to carbonate and bicarbonate, that will be 2 into that of carbonate alkalinity plus bicarbonate alkalinity. So that's about the alkalinity experiment. Hope you understood the concept. And thank you very much for watching my video, and have a nice day.